All right, so here's your free response question of the day. This is the actual question that was in the 2019 exam. So this is the actual free response question from a year ago, one of the six. So we're going to go through it now. Um, you're given a graph. Have you noticed there's a lot of questions where you're given a graph and then it's defined as an integration for something else? And you have to have the skill to know that when you integrate with the graph, you find the area under the curve and how to do that. All right, so the function is continuous and closed from -6 to +5. So this is only to -2. So there's something else that goes all the way to -6 that we don't know about. The figure above shows a portion of the graph of f, and it consists of two line segments and a quarter of a circle centered at the point 5, 3. It is known that 3 and 3 and -5 is on the graph. So there's a point, maybe we need to know that point when that comes to it. All right, so part A, now notice in this one, I don't have room on this page to answer it, so I'm going to go to another piece of paper here, and we're going to start. So for 3A, it says, if the integration from -6 to 5 of f at x dx equals 7, find the value from -6 to 2. I think that says the word find. Find the value of the integration from -6 to -2 f at x dx. So that's my goal right there. All right, so from -6 to 5, that's the entire integration. From -6 to 5, I know that answer. So this is my goal, by the way. Let's just set this up as an equation. So I know the whole shebang from -6 to 5, f at x. If I take the whole thing and I subtract, see, I want -6 to 5. This is -6 to -2. So if I subtract from -2 to 5, then what's left over is what I'm looking for. So this is everything from -6 to 5. This is -2 to 5. So if I subtract it, what's left over is -6 to -2. Just some basic kind of thinking arithmetic with integration. So I already know -6 to 5. It says in the question, -6 to 5 is 7. So I already know this is 7. And then I'm going to subtract what this answer is when I integrate from -2 to 5. So how do I do that? So let's look through that. So first of all, if I'm going to go -2 to -1, there's a triangle on top and a triangle underneath, and they're the exact same area with the same slope, so they cross out. So that leaves me here with understanding what I'm left with. So I'm not going to assume this, what that is, but I need to know that point of intersection. So I need to know that equation line. That's going to help. But I know the y-intercept is -1, and I know the slope is up 4 and over 2. So it's 2x minus 1. That's going to help. So on the side, I'm going to write down y equals 2x minus 1. If I make it equal to 0, there we go. What is that x-intercept? So if you add 1 and divide by 2, you can see that x value is 1/2. So if I want to find the area of that little triangle underneath there, it's half of a half times 1. So 1/2 times 1/2. So half of a half times 1. And I know that answer is going to be negative because it's below. So there's a start. Next, we have another triangle right here that I'm going to find the area of. And so 1/2 to 2. So what is that? That's 1.5, or 3 over 2. If I have room here, this is going to be positive. So again, the area of the triangle. And then what's the height of it? Up 1, 2, 3. So half of 1.5 times 3. There's the second triangle. That one's positive because it's above. And now this one's a little bit tricky. So if I find the area of the quarter circle, like if I find this area here, which is the actual quarter circle, that's not the area under the curve. So what I need to do instead is understand this part here as a rectangle and take that, or is it a square even? Is it 3 by 3? It's a square. So 3 by 3, and then subtract the quarter of a circle, and what's left over is what I need. So I need the square and the quarter circle, and then I subtract them, and what's left over. This is the part I need. I'm going to do it in dark. The part here underneath, that's the part I need. So to get that part, I need to understand square, take away a quarter circle, and what's left over is what I need. So the square is 3 by 3, which is 9. And then I subtract the quarter of a circle. Now to find the area of a circle, it's pi r squared. And the radius of that is 1, 2, 3, right? And then divide by 4. So that I don't need to reduce down. But understand what I did. So I had 7 subtract. I had a little triangle underneath. I had a bigger triangle above. And then I took the square, subtract the quarter circle to know the area underneath the circle. And I don't need to reduce it down. That is the answer. From -6 to -2 f of x dx. Done. All right, that's just part A. Let's look at part B. All right, so in part B it says, evaluate from 3 to 5, 2 times the derivative of f of x plus 4 dx. So how am I going to do this one? So to start with, and understand that when I take the integration and the derivative, they undo each other. And then when they undo each other, you're just left with f of x, and you're going to plug in from 3 to 5. Then that integration also belongs to the 4. So when you integrate 4, that's 4x, and that's also going from 3 to 5. And that's what we're going to use to then evaluate it. So I need to understand. So first of all, plug in 5. Subtract, plug in 3. Plug in 5. Subtract, plug in 3. Now look off the graph. What is f at 5? So when x equals 5, what's the answer? And the answer is 0. So the y value when x is 5 off the graph is 0. That's nice. What's f at 3? Well, that's what I needed, that weird point. Remember that weird point, 3 and 3 subtract root 5? So the answer there is 3 subtract root 5. That's why I needed to know that from the question. 4 times 5, I got that one. -4 times 3, I got that one. And that's a great answer right there. You've done all the work that you need to do. You don't need to simplify it further. For fun, you go 8 take away 6. That's 8 take away 6 is 2. And then you would have minus root 5. But you don't need to do that. This is good, right? Like that. Don't even like pretend like you're going to have a bad day doing that. So I had -6 and 8. That's 2. And then you have negative and negative is root 5. So do you really want to know that you distributed correctly and that you did that correctly? That's fine, but you don't need that, right? You can have a bad day with that. I can have bad days with that. So just leave it with that. All right, part C. So in part C, it asks, the function g is given by g at x is equal to, common question, right? They take a secondary function, define it with that graph. So from -2 to x, f of t dt. And then it says find the absolute maximum value of g on the interval from -2 to 5. So what we see from -2 to 5. So my goal is to find the absolute maximum. I know that when I take the derivative of this, it's equal to f of x. That's using the fundamental theorem of calculus and understanding that. So the function tells me whether it increases or decreases. So we're going to follow along here to understand what that could be. So first of all, to know that the absolute, we're going to start with the end values. So the first end value is when x is -2. So we're going to plug in -2. So when I plug -2 into this function from -2 to -2, the answer is 0. The next one I think about is when is this derivative, or when is the function equal to 0? So it's equal to 0 when you look off the graph on the x-intercepts. That's -1, and we already found this one, +1/2. So -1, +1/2, that's where it touches the axes. It also does at 5, and that's at the end of the graph anyway. So that's one end to the other end, and where it's equal to 0. So for each one of these, I'm going to plug this into this equation. So it says for -1, what is the integration from -1, or from -2 to -1 of that function? So what does that equal? So from -2 to -1, what's the area of that triangle? So half the base times the height, so half of 1 times that, it's 1/2. Again, we're looking for the absolute maximum value. At +1/2, what would it be? So you're integrating from -2 to +1/2. What would that look like? So from -2 to +1/2. Remember we said that these triangles, they cross out. So you're just left with this negative little triangle there, which is actually -1/4. And we did that work before. Half the base times the height. So again, these triangles cross out because one's positive, one negative, and they're the same size. You're left with this little triangle that's negative down here, and that's a half. So what's half times a half? Like half the base times the height, and you get -1/4. Not our answer anyways, because we're looking for the greatest value that's been. So far, our greatest answer is 1/2. So we have one more to go, that's 5. So what is the answer from -2 to 5 for f of t dt? We just did this one in part A. What was our answer in part A? But we didn't simplify it. So now we might have to simplify it to understand if that answer is bigger than 1/2 or not. So when I did that, I got 7 subtract. Now I'm going to simplify this to -1/4 plus 9/4 plus 9, take away 9 pi over 4. So let me simplify that further so I can understand if that answer is bigger than 1/2 or not. So I'm going to go, the denominators are the same. So 9 take away 1 is 8, and 8 divided by 4 is 2, plus 9 is 11. So I get 11. Oh, and I don't need the 7 in front. Because this 7 in front is not going to help me from -2 to 5. That was part A, where the 7 was part of it. This is not a part of it. 7 minus was only for part A, because it was not asking from -2 to 5, but it was asking that. So from -2 to 5, it's just this part, and you end up with 11 take away 9 pi over 4. And whether that answer is bigger than 1/2. And it is. Think of pi like 3. So 27 divided by 4, it's about 7, not quite 7. So 11 take away 7, like it's definitely bigger than 1/2. So having some number sense, that answer is larger than 1/2. So therefore, at x equals 5, g at x has an absolute maximum value of 11 minus 9 pi over 4. And it's done. All right, 3D, last one. In 3D, it says find the limit. I like these limit questions. As x approaches 1, because I think they're simple, honestly. And most of the time, it's L'Hopital's rule. It's just setting that up right and knowing what you're doing just a little bit. But the math itself, I don't think is usually terribly difficult, and it's like easy points to get. So to write this out, I'm going to change the numerator by itself. So 10 to the x minus 3 times the derivative of f at x, and then know what that equals when I plug in 1. So 10 to the 1, that's 10. Now, when I plug in 1, it's saying, what's the derivative of f at 1? So the derivative at 1 is the slope of this whole line, which is up 4 over 2, or just 2 over 1, which is 2. So this is not going to be L'Hopital's rule, because the numerator is not 0. It's 4. So I could actually, now I feel more confident that I can actually just substitute in terms of what I need. So I did this work thinking the answer might be 0, and I didn't want to write down 0 over 0, but now I can come back up here and know that the answer is 4. When I look at the denominator, I can still separate it and do the work. F at x minus arctan x. So what's the value of the function at 1? So plug in 1. What's the y value at 1? Look off the graph, and it's positive 1. So at 1, the answer is positive 1. And then this is the harder part, knowing your unit circle. But honestly, you could write down arctan 1, and it would be okay. So that answer is pi over 4. At what angle is tangent 1? It's pi over 4. But it's okay to write it even with arctan in the answer. So we're going to go 4 over 1 minus arctan 1. You could also write the answer as 4 over 1 minus pi over 4, and both are correct. All right, you just did it. Question number 3, you did your free response question for the day. I'm proud of you. Thank you for doing your work. Mr. G Math, over and out.